Okay, so polar bonds and polar molecules. A molecule which contains a polar covalent bond can be overall nonpolar. Okay? The individual bond dipoles are vectors that can be added to each other, and because of this they can cancel out, right? So if a bond dipoles are equal in strength and opposite in direction, okay, they're going to cancel each other out, resulting in a nonpolar molecule. This canceling happens in symmetrical molecules. So if the bond dipoles do not cancel, then the entire molecule is going to have a slightly positive and slightly negative end, which are going to be called its dipoles. So here are the general rules. Tetrahedral is nonpolar if all atoms attached have the same pull, in or out, polar if different atoms are attached. A trigonal planar is nonpolar if all atoms attached have the same pull, in or out, and polar if different atoms are attached. A pyramidal is polar as long as there is a difference in electronegativity between the atoms. Bent is always polar, and linear is going to be polar or nonpolar, and you have to look at the electronegativity difference. So, here are our examples. And with this, what I would like you to do is I would like you to pause this video, okay? Draw these examples yourself, okay, in their particular orientation, and then make the guess as to whether or not they are polar or nonpolar. So that way then, if you have any questions or there's any misunderstandings, then you're going to be able to check it with the answers that are going to come later in the video. So take this time right now to pause the video and do the examples. Okay, so now that we're back, we have H2O, which has a bent orientation. Okay, the dipoles are in this orientation. Because of this, no matter what, and the fact that it's bent and it really doesn't matter, it's going to be a polar molecule. Okay, we have HCl. Okay, there is an electronegativity difference, so this one is polar as well. This is particular molecules in a linear orientation. Okay, it's on either side. This is going to be a non-polar molecule. Okay, because the two vectors are going to cancel each other out. Okay, if we look at this particular one, both vectors are pointing in the same direction. Okay, the middle one it's a non-polar bond, and because they're all pulling in one direction, we're going to have a polar molecule. Alright, so what I would like you to do now is to try these examples, okay, and we'll have the answers for you in the next video.